Hi, my name is Ali Shirsavar, and in this video we're going to talk about how we measure the differential mode insertion loss of an EMC filter. Okay, so let us start with the basic structure of an EMC filter first. So I typically start right here. I get my common mode choke, which looks something like this. And then I have some common mode capacitance, looks like that. And then the leakage inductance of this common mode choke acts as a differential mode inductance. We have done other videos about this, and we also run an EMC filter design workshop. But for now, I'm going to represent the leakage of this common mode choke as my differential mode inductance. Let's call this LDM and LDM. And then I have my differential mode capacitor here. So I would like to measure the differential mode insertion loss of this filter, and unlike common mode, when the currents were both going in the same direction, for differential mode one current is going this way and the other current is returning. Now if I inject for measurement purposes a differential mode current as opposed to a common mode current, so the current is going this way and it's returning, then the common mode choke itself actually disappears as far as the differential mode current is concerned, because the current going this way cancels out with the current that way. What we are left with is the leakage of the common mode choke, which of course we use as our differential mode inductance. And as I mentioned earlier, we have done other videos about this, and we run a workshop. This is connected to my chassis. So this is left out of the picture. I still have these two small capacitances. They do appear in my insertion loss. However, please note that these common mode capacitors are very, very small, and they are in series with each other and they're equal size. So even they're small to start with, and because they're in series, their value halves. So I'm going to assume that this is also negligible when it comes to my measurement. So I therefore end up with my differential mode inductance there, my differential mode capacitor, and my differential mode inductance on the way back. This is my line, this is my neutral, this is my line, and this is my neutral. So in an ideal world, I'd like to measure the insertion loss of this filter. However, if I put my injected signal here and the ground here, and my measurement probe here and the ground here, you can imagine that the ground of the measurement probe will actually short this out. So I end up shorting this out with the ground of the injection signal, so that will be on the same ground as that, and then that will be a wrong measurement. So somehow I need to isolate this, and inject my signal differentially in a way that I don't short this bit out. And I do that with the transformer. So imagine that I have got a one-to-one transformer there. I'm isolating it effectively from there to there and from there to there. That's a one-to-one transformer that we actually call a balun, right? And then I need to put another one on this side. There we go. That is another one-to-one, identical to that one-to-one transformer. Again, it's a special type of transformer we call a balun. And note that we are wanting to inject a differential mode signal, right? So let me get a different color. If this is a sine wave like this, I want the signal down here to be in the opposite direction that way. So somehow I need to balance this in a way that the sine wave that my instrument is injecting on this side is a mirror of that side. And of course, I do that by using a center tapped balun. And if this is the center, half of the signal is going to appear on this line, inversion of the signal is going to appear on that line. I am differentially injecting my signals, and then all I have to do is get my Bode 500. I connect my signal generator part here that is connected to the chassis, and I put my receiver channel here of the Bode 500, and that is also connected to the chassis. I am injecting a signal differentially across here. I am measuring it on the other side. The instrument will automatically measure the size of the signal going in, the size of the signal coming out, and plot the insertion loss for me. So I have got a lab set up. We're going to go to the lab and we're going to make the real measurement. Okay, so here I've got a test set up. As I described on the board, I need some one-to-one transformers in order to isolate the signal so that I can measure the differential mode insertion loss. And these are the two balloons that I have connected to my filter. You can see that on the primary side of the balun I've just got one BNC connector, but on the secondary I have got access to the center tap, which is what I described on the board. So what is happening now is that I am injecting a signal through here with my Bode 500, then that is split with a center tap, and a differential mode signal is being sent through here, and then I'm measuring what is coming out of this identical transformer on the output, and then of course the Bode analyzer suite will automatically plot the insertion loss for me. So let me connect it up and we'll see what it looks like. So that is the injected signal. That is my signal that's coming out, and there we go. So here is the insertion loss. You can see that at 10 kilohertz I've got just over 20 dBs of insertion loss, and then the insertion loss just increases. So the amount of signal that is coming out is a lot smaller, up to around 1 megahertz, after which it starts to go flat. And of course this is a differential mode signal, so its frequency is lower compared to the common mode. Now let us have a look at the commercial one. This one is from Wurth Electronics, and here is my REDEXPERT. So, and I have found one that looks similar, and if I expand that, you will see that they have got almost exactly the same shape. So insertion loss goes up with frequency quite a lot, and then around 1 megahertz it starts to flatten. They've even got exactly the same kind of resonance that appears at higher frequencies. So there we go. This is how we measure the insertion loss of the differential mode filter. I hope you enjoyed the video. We run EMC filter design classes in North America and in Europe regularly. Hope to see you at one of our workshops. Thank you very much for watching.